In this video, we will be covering the chapter number 10 from the class 9 textbook of mathematics for CBSE. So chapter 10 deals with the topic of Heron's formula, and this chapter is a very short chapter, but for the sake of completeness, I will be covering what is the idea of this chapter. It's a very short chapter, as I said, and also a very simple idea. Basically, it gives the formula for calculating the area of a triangle when we don't know the height of the triangle. So when the only information available with us are the three sides of the triangle and there is no way of finding out the height of the triangle, in that case, what is the procedure to find the area of the triangle? We know in general that the formula for calculating the area of a triangle is half into base into height. But in situations where we are not having the information about the height of the triangle, and if we have only the lengths of the three sides of the triangle, how do we calculate the area of the triangle? And this is where Heron's formula becomes useful. So if we know the lengths of the three sides of the triangle, so let's say the three sides have lengths A, B, and C, then Heron's formula allows us to calculate the area of the triangle according to this expression over here, where the expression for the area of the triangle is the square root of s into s minus a into s minus b into s minus c, where a, b, and c are the three sides of the triangle, and s is called as the semi-perimeter of the triangle. So we know the perimeter of any shape is the sum of the lengths of its sides. So in a triangle, we have three sides. So the lengths of the three sides are A, B, and C. So the perimeter is the sum of the three sides, which is A plus B plus C. And this parameter S is half of the perimeter. So it's A plus B plus C divided by 2. So we call this as the semi-perimeter of the triangle, which is basically the perimeter of the triangle divided by 2. So this parameter S is the perimeter of the triangle divided by 2, and we call it as the semi-perimeter of the triangle. So once we know A, B, C, from the values of A, B, and C, which are the sides of the triangle, we can calculate the semi-perimeter of the triangle S, and then using S and the values of A, B, and C, we can calculate the area of the triangle as per this formula, which is called as the Heron's formula. So let's work out one example and see how we are able to get the area of this triangle. Given the lengths of three sides, so the length of one of the sides is 40 meters, the other side has a length of 24 meters, and the third side has a length of 32 meters, and we are asked to find the area of the triangle. So let us call these lengths as A, B, and C. So A is 40 meters, B is 24 meters, and C is 32 meters. And from these lengths, we can calculate the semi-perimeter S, which is the sum of the three sides divided by 2. So it's A plus B plus C, the whole divided by 2. So we get that as 48 meters. Okay, so we get S equal to 48 meters. And now we can apply Heron's formula to get the area of the triangle. So area of the triangle is the square root of S into S minus A into S minus B into S minus C. So we already have the value of S as 48. So it's square root of 48 into 48 minus A is 40. So 48 minus 40 into 48 minus 24. That's S minus B, and B is 24. So we have 48 minus 24. And S is 48, and S minus C is 48 minus 32, because C is 32. So now we have 48 into 48 minus 40 is 8, 48 minus 24 is 24, and 48 minus 32 is 16. So we have 48 into 8 into 24 into 16 under the root, and that gives us the area of the triangle. So all we need to do is to compute the square root. So 48 into 8, we get 384. And 24 into 16 is also 384. So the square root of 384 into 384 is basically square root of 384 square. So when you have a square and a square root, they both cancel out each other, and we end up getting 384 as our answer. And since we are dealing with the area, the unit of area is square of the units, okay, square units. So since the units are given in meters, so we get it as meter square. So we have the area of the triangle has been computed here without using the half base into height formula. Okay, we have used the Heron's formula here, where we have the lengths of the three sides A, B, C given to us, and from that we computed the semi-perimeter, which is A plus B plus C by 2, and from that we applied those values into the Heron's formula and obtained the area of the triangle as 384 square meters. Okay, so it's a fairly straightforward concept in this chapter, where we are going to compute the area of a triangle just by knowing the values of the three sides of the triangle. Okay, so let's do one more example here. In this example, we are given two sides of the triangle as being 8 centimeters and 11 centimeters. We are also given the perimeter of the triangle as 32 centimeters, and we are asked to find what is the area of the triangle. So we know already that the perimeter is the sum of the three sides. So let's write down the lengths of the two sides which are available to us. Okay, we have been given that one of the side measures 8 centimeters and the other measures 11 centimeters, and we are given the perimeter, so therefore we have to compute the length of the third side. So let us first give some name to the two sides which are available to us. So let A equals 8 centimeters, B equals 11 centimeters. We don't know what is the third side C. We know, but however, the perimeter is the sum of the lengths of the three sides. So perimeter equals A plus B plus C. C is the value that we don't know. The perimeter value is given as 32, and that equals A plus B plus C. A is 8 plus B is 11 plus C is the unknown value of the third side. So 11 plus 8 is 19 plus C equals 32. So we can have 32 minus 19. We take the 19 to the other side as being equal to C. So that will give us the value for the third side C for the triangle. So we have 32 minus 19 is 13 equals C, or in other words, it's the same as saying C equals 13 centimeters. Okay, so we now have all the three sides of the triangle. So the three sides of the triangle are now A equals 8 centimeters, B equals 11 centimeters, and the third side C equals 13 centimeters. Okay, and we know that the parameter S that we use in the Heron's formula is the semi-perimeter. S equals perimeter divided by 2, which is nothing but A plus B plus C divided by 2. But we know already the value of the perimeter is given to us as 32 centimeters. So we don't need to add ABC once again. We already know that sum as 32 by 2, which is equal to 16 centimeters. So we have now obtained the value of the parameter S, which is the semi-perimeter, which is equal to 16 centimeters. Now, according to Heron's formula, the area of the triangle can be computed. So by Heron's formula, area of triangle, so I'll just write triangle equals S into S minus A into S minus B into S minus C. This whole thing is under the root. Okay, so that gives us the value of S we have obtained as 16, and 16 minus A is 8, so we have 16 minus 8 into 16 minus B, B is 11, and 16 minus C, S minus C is 16 minus the value of C we have obtained as 13, and this whole thing is under the root. Okay, so we just have to compute this value, and that will give us the area of the triangle. So that is equal to 16 into 16 minus 8 is 8 into 16 minus 11 is 5, into 16 minus 13 is 3. So we have to compute the square root to obtain the value of the area of the triangle. So we can do some simplification here. 16 into 8 into 5. So 16 into 5 is 80. So we have 80 into 8 into 3. So this is not going to be a perfect square inside the square root. So to simplify our calculations, I'm just rearranging the numbers. So I basically multiplied the 16 with 5. So 16 5s are 80 into 8 into 3 we have as it is. So now we can write this 80 as 8 into 10. So we can write the 80 as 8 into 10 into 8 into 3. Okay. Now we have two 8s here. 8 into 8 is 64. So that will be square root of 64 into 10 into 3. 10 into 3, that's the whole thing under the root. So we can take the 64 outside the root. So square root of 64 is 8. So we have 8. Square root of 10 into 3 is 30. So we can leave it as it is. Okay, we can 30 does not have the square root of 30 would be in decimals, so we can leave the expression as it is here. So the area of the triangle, we can write it as 8 root 30, or if you want to go ahead and find out what is the value of root 30, find out and multiply it with 8, and that will give you some number, but it is sufficient if we even leave it at this point. So it is 8 times root 30, and since the unit is centimeters for the length, the area will be centimeter square. So we have the area of the triangle as 8 times root 30 centimeter square. So let us now do one more example for computing the area of the triangle using the Heron's formula. So in this example, we are given that there is a triangular park with vertices A, B, C, and the lengths of the sides of the park are 120 meters, 80 meters, and 5 meters. So the three sides of the triangle have lengths 120, 80, and 5. So let's call the three sides as A, B, and C. So let me write this as solution. Okay, solution. Let A, B, and C be specified now. So let A equals 120 meters, B equals 80 meters, and C equals 5 meters. Okay, just make a correction. The value of C, the third side, is 50 meters, not 5. Okay, so it's 50 meters. Okay, so the three sides given in the question have values 120 meters, 80 meters, and 50 meters. Okay, I had incorrectly written it as 5 meters. The actual value in the example is 50 meters. Okay, so C equals 50 meters. Okay, now we are asked to find what is the area of the triangle. So a gardener has to put a fence all around it and also plant grass inside it. So we are asked to find how much area does she need to do the plantation for the grass. So that means we have to find the area of the park. And we are also asked to find what is the cost of fencing it with a barbed wire at a rate of some amount per meter of the length, which is given to be 20 rupees per meter of barbed wire. And we are asked to leave a space of 3 meters wide for a gate. So basically, first thing we have to do is we have to find the area of the park, which is basically the area which has to be covered by the grass. So, okay, that's the first part. The second part is we have to find the perimeter of the park. So perimeter is basically the sum of the three sides. But from the perimeter, we have to leave out 3 meters for the gate, because the gate part will not be fenced. So from the perimeter, we have to subtract this 3 meters, and that will give us the total length of the barbed wire that is required for fencing, excluding the 3 meter gate part. And once we have the total length of the barbed wire, given that the length per meter, the price per meter is 20 rupees, we can multiply this 20 with the length of the barbed wire to get the total cost of fencing the park with the barbed wire. Okay, so that's the two parts. So let us do first the area of the triangle, and for that we will use Heron's formula. So area of triangle is S into S minus A into S minus B into S minus C under the root. So we need to first calculate S. So S is A plus B plus C divided by 2, which is 120 plus 80 plus 50 divided by 2. So that is basically 120 plus 80 is 200 plus 50 250 divided by 2 is 125 meters. So we have the value of S as 125 meters. And now we can calculate the area of the triangle. Area of triangle equals S is 125 into S minus A is 125 minus the value of A is 120 into S minus B is 125 minus 80 into S minus C is 125 minus 50. So we have substituted all the values that are available to us into the formula. So we now get this as 125 into 125 minus 120 is 5, and 125 minus 80 is 45 into 125 minus 50 is 75. Okay, so we need to multiply all these numbers and then take the square root, and we'll see what the answer is. So I'm just going to rewrite this particular expression on the next page so we can follow it easily. So the area of the triangle is the square root of 125 into 5 into 45 into 75, which is what we have here. I've just copied that all over again on the next page. And now we can go on to simplify this. An easy way of simplifying values inside the square root is if we have the same number repeating twice inside the square root, we can take it out once and remove that number. So let's see how we can do this. For example, 125 can be written as 25 into 5, right? So I have written this 125 as 25 into 5, and then we have this into 5 again, so that's into 5. And then 45 can be written as say 15 into 3. So 15 into 3 is 45, and then 75 can be written as 15 into 5. 15 5s are 75. Okay, so I've just broken down those numbers by using their factors. So now whatever numbers occur inside the square root 2 times, we can take it out once and get them outside the square root. So we have the number 5 here occurring 2 times, so we can take it outside the square root. So we can take that 5 out, and similarly there are 2 15s inside the square root, so you can take that 15 outside the square root, so into 15. And then what we are left inside the square root are the remaining numbers, which is 25 into 3. So we have taken out these 2 5s, they occur twice. We have taken out the 15 and this 15. So what we are left inside the square root is this 25 and this 3 and the other 5. So it is into 5. Okay, so I'm just making these calculations easier, so we can compute the value in an easier way rather than having to compute the square root of a very big number. Okay, so we have this now as 15 into 5 is 75, and inside the square root we again have 25 here, so that 25 can be written as 5 into 5 again into 3 into 5. So there are again 2 5s here which can be taken out outside the square root. So we will get the 75, which is already there. So these two 5s inside the square root can be taken out once outside the square root. And what we are left inside is square root of 3 into 5, which is basically square root of 15. So 75 into 5 into square root of 15. So 75 into 5 is 375 into square root of 15. Okay, we cannot simplify square root of 15 any further, so we can leave it as it is. And the unit of the area is meter square. So we have the area of the triangle as 375 meter square. Okay, so that's the area of the park which needs to be covered by the grass. So the gardener has to plant grass in an area equal to 375 times square root of 15 meter square. Okay, that's the first part of the question. The second part of the question is to find the cost of the barbed wire to put a fence all around the park except for a 3 meter space which will be left open for the gate. So we need to basically find the perimeter of the triangle and then subtract 3 meters from the perimeter. So that will give us the length of the barbed wire required for the fence. Okay, so the second part, I'll just call it the second part here. So the second part is we first find the perimeter, which is A plus B plus C. So the values of the 3 sides of the triangle are 120 meters, 80 meters and 50 meters. So we have the perimeter as 120 plus 80 plus 50, which is equal to 250 meters. Length of the barbed wire, or the length of the fence, equals the perimeter minus the width of the gate. Okay, because the gate part we are not going to fence, so minus the width of gate. So that becomes the perimeter is 250 minus the width of the gate is given to us as 3 meters. So that becomes 247 meters. So we have got the length of the fence as 247 meters. The next thing we need to do is to find the cost of the entire fence. We know from the question that the cost of the fence per meter is 20 rupees. So we can find the cost of the entire fence by multiplying the cost per meter with the total length of the fence. So let's write that down. See, the cost of fence per meter equals rupees 20. Length of the fence is 247 meters. So the total cost of the fence is simply we have to multiply the length of the fence with the cost of the fence per meter. Okay, so basically we have to multiply 247 with the cost per meter, which is 20, and that will give us the answer for the total cost of the fence, which is equal to 4940 rupees. Okay, so let me write that rupees in the rupees symbol in front, and 4940. Okay, so the total cost of the fence, that is the cost of the barbed wire, is going to be 4,940 rupees. Okay, so we have seen these examples here, and we'll see a couple more examples from this chapter, and that will be the end of this chapter. Okay, it's a very short chapter and a very simple chapter. Basically, Heron's formula allows us to compute the area of the triangle when the height of the triangle is not available to us and there is no way of calculating the height of the triangle, and we have knowledge only of the three sides of the triangle. So using only the three sides of the triangle, how can we calculate the area of the triangle? We can use the Heron's formula to perform that, to find that area. Okay, so we'll do some more examples in the next video.